Okay, so we're going to have writing matrix equations for systems today. On our first example, we're going to be given a system and the equation. We're going to go write it as a matrix. Before we do that, we have to make sure these are both in standard form. So in the first equation, we just bring that 6x over here. So we'd have 6x plus 10y is going to equal -2. And then on the second one, we just have to flip these. So you have your 4x plus 5y is going to equal -8. Now, when we have our matrix, your first matrix is just going to be consisting of the coefficients of these. So we have 6, 10, 4, and 5. And then you multiply by a matrix of the variables that are in the problem. So you have x, y. Then you set it equal to your answers. So you have a -2 and -8. So this is the matrix that represents this problem right here. Now on the second one, what we're going to go is we have a matrix, but we have to go into an equation. So if you think back to when we multiplied matrices, remember we said row times column. So if we were to just take this row and multiply it back through this column of variables, you would have that -6x minus y minus 2z, and then we'll have it set equal to our answer over here. So equals -20. And then we're going to do our second row. So we have a -5x plus y plus 3z is going to equal 15. And then our last one would be 2x minus 6y minus 2z. And that's going to equal -22. So this is the system that represents from this matrix right here. Now our last one says, what is the inverse matrix to solve the system? Since technically we cannot divide matrices, you actually find the inverses of your coefficients and you multiply to the answers to get your final product on this. But all I want to know is, what is the inverse matrix that represents this problem? So we're just going to go ahead and focus just on the coefficients. So we have 2, 10, 10, and 1. And then we have to find the determinant first. So our determinant is going to equal, remember, you take these two numbers and you multiply them, minus the product of these two, so you have 100 here. So it's going to equal -98. Now, for our inverse, remember it's 1 over your determinant, so we have a -1 over 98. Then we take this diagonal here and we flip it, so we have a 1 here and a 2. And then these ones we just changed their sign, so -10, -10. And then we want our two answers here. So we're just going to take this -1 over 98 and multiply it through the matrix. So we're going to have our first element, -1 over 98. Our next one's going to be 5 over 49. And then we're going to have 5 over 49. And then our last one's going to be -1 over 49. So we have our sort of two inverse matrices that we use to represent this problem right here.